Hello, trigonometry slash pre-calc students. I'm going to try and explain here what the heck this means. The sine of the inverse tangent of x. And I'm going to use this over here to try and explain it. So that right there is a theta. Kind of looks like a zero, but there's a line in it. So that's a theta, as in a Greek letter that is typically used for an angle. Don't ask me why, but it is. So that angle right there we're going to call theta. So forget about this over here for now. Let's focus on this, and this hopefully will explain what's going on. So if you just have a typical right triangle, then SOHCAHTOA, sine, cosine, and tangent, opposite over hypotenuse, all that. You got sine of theta here would be 3 over 5 in a 3, 4, 5 triangle. Tangent of theta would be 3 over 4. Let's say we wanted to know what theta actually was. What is that angle? And we're going to use the tangent of theta as 3 over 4. We're going to have to get theta all by itself. So we're going to have to move tangent to the other side. You know, if you want to solve for something, you got to get that variable all by itself. So we got to get the theta all by itself. And when you move tangent to the other side, it becomes the tan to the negative 1, which is called the inverse tangent. Some people refer to it as the arctangent. I like inverse. So theta is the inverse tangent of 3 over 4, and that's essentially what we have here. But with this type of triangle, still a right triangle, but now instead of 3, 4, 5, you have an x and a 1. So tangent of theta is now x over 1, and if you want to solve for theta, you do the inverse tan, and you get the inverse tan is equal to x over 1, and anything over 1 is just the numerator. So it's basically inverse tangent of x, and that's what we have here, inverse tangent of x. So theta is equal to the inverse tangent of x. So I'm going to go ahead and say that sine of theta is what we're actually trying to solve for here. Sine of theta and sine of the inverse tangent of x is the same thing because the inverse tangent of x and theta are the same thing, which is what I just tried to show you here. Theta and inverse tan of x are the exact same thing, so we can substitute them out. So now what is sine of theta? Well, we got to use the same triangle that this came from, which is this one down here. So the sine of theta is the opposite over the hypotenuse, so it's the sine of theta is equal to x over the hypotenuse, opposite over hypotenuse. We just don't know what the hypotenuse is, so we got to use the good old-fashioned Pythagorean theorem to figure that out. We got to square both these sides and add them together, so that's hypotenuse is going to be equal to x squared plus 1 squared. I could just say that's c, you know, the old a squared plus b squared equals c squared. But I called this side here h for hypotenuse. I actually called it hyp for hypotenuse. So the hypotenuse is equal to x squared plus 1 squared. 1 squared is just 1. So it's equal to x squared plus 1. And I kind of lied. Pythagorean theorem is not just hypotenuse, it's hypotenuse squared. It's c squared is equal to a squared plus b squared, right? C squared is equal to a squared plus b squared. That's Pythagorean theorem. So c is our hypotenuse, a and b are x and 1. 1 squared is 1. So we just figured out what the hypotenuse squared is. It's x squared plus 1. If we want to just know what the hypotenuse is, we have to unsquare it, take the square root. So the hypotenuse would be the square root of x squared plus 1. So that's our hypotenuse, x squared plus 1. So I'm going to go ahead and write that in there. Let me rephrase the square root of x squared plus 1. So there you go. So there's our hypotenuse, the square root of x squared plus 1 from the good old-fashioned Pythagorean theorem. Now we can do sine of theta. It's x over the square root of x squared plus 1. And that is the goal of that problem, to figure out what sine of theta is. And you just did it. I guess technically I did it, but hopefully you can do that now if you follow these steps. And the sine of theta is equal to x over x squared plus 1.